Hi there everyone. So in this video I'm just going to go over the information that was presented to you in the Nearpod lesson this week. So first a little bit of review with forces, and then we'll go into Newton's laws. So force, as you guys probably remember, is defined as either a push or a pull. The unit of measurement for force is the Newton, and we measure it using something called a spring scale, which is what you see in this picture here. When we have multiple forces acting on an object, we can either consider them to be balanced or unbalanced. We will have a balanced system when we have equal forces acting in opposite directions, which result in a net force of 0. And that's what we're seeing here in this example with this box, right? We have equal forces of 5 newtons on both sides, both pulling in opposite directions, and that results with a net force of 0 when we work out the calculation. Same thing with this guy down here too. We wind up, these are 3 pushes, but when we wind up doing the math and the calculations, we do find that the net force in this case is also 0 newtons, which means this is another balanced system. Unbalanced forces occur when we have unequal forces resulting in a non-zero net force. That means a net force that is not 0. So if we look at this one over here in the top left, we see that we have 2 forces acting on this box, both pushes. This results in a net force of 45 newtons going towards the left, and this would also result in the movement of the box. Same thing, similar scenario here, right, where we have multiple forces acting on the box. When we work out the calculations, 50 plus 30 minus 20, because the 20 is going in the opposite direction, we have a net force of 60 newtons going to the right, and that's the direction in which the box will move. Friction. Friction, you might recall, is affected by the types of surfaces involved and how hard those surfaces are pushed together. The more quickly and the harder you push your hands together as you rub them, the more friction will be generated and the more heat will also be generated. Types of surfaces involved, right? We talked about this with the Port Bear. Ice is slippery. Ice, therefore, we probably already knew, has very little friction, so it's very easy to slip and fall on a smooth surface because it doesn't have very much friction. When we think about things like carpet or concrete or just asphalt, those are rougher surfaces. Those have more friction. Those are harder to, slip and fall on. Gravity is affected by both mass and distance, so we know that the greater the mass, then the greater the gravity. The greater the distance, then the less the gravity there will be. Weight, as you might recall from our conversation last week, is the measure of the force of gravity on an object, whereas mass is just the amount of matter in an object, and mass will remain constant, whereas weight will change depending on the gravity that that object is experiencing. Then another just important thing to remember is that gravity is an attraction force. That is the reason why when things fall, like this guy with the basketball and the tennis ball, things always fall downwards because gravity is pulling everything towards the center of the earth. And now something new, Newton's first law. So Newton's first law states that an object at rest will remain at rest and an object in motion will remain in motion until acted upon by a non-zero net force. It is also known as the law of inertia, where inertia is the resistance to change in motion. So if we think about this guy on the motorcycle, he and the motorcycle are both moving, but the motorcycle hits a wall, so the motorcycle has received a force that has stopped its motion. However, the guy being on a motorcycle doesn't have a seatbelt. There's nothing to stop his motion. So he unfortunately goes flying, flying, flying until the ground provides him with a force that then stops his motion. If you look at the scenario down here with the soccer ball, then the soccer ball is clearly at rest, and it's going to stay at rest until something comes along to kick it, and then that soccer ball will stay in motion until something comes along to stop it, like the net or the friction between the ball and the grass. Newton's second law tells us that an object's acceleration depends on its mass and the net force acting on it. So this means that the more mass we have, we will require a greater force to be able to move it at the same acceleration. Similarly, let's say in the scenario here with the people on the cart, right, this one, if we don't have the additional force, right, it's still just one person pulling the cart, then we're also going to see a significant decrease in the acceleration because this person has a lot more mass to move around. Whereas in the first upper scenario, less mass, greater acceleration. All right, so just important things just to keep in mind. If the mass is larger, then we're going to see a smaller acceleration, unless if we see an equally large force with that large mass. And then finally, Newton's third law tells us that for every action, there is an equal but opposite reaction. So here are the two examples that we have here. So we see first the example with the rocket. There is a force that pulls, that goes to the right, and that results in an equal but opposite force that goes to the left, right? So the force to the right is the hot gas exploding from the rocket, and the force to the right is the rocket moving forward. Similarly, we have this scenario with the person pushing off the wall as they're swimming in a pool, right? So the force of their feet on the wall creates an additional force that pushes in the opposite direction and allows them to propel themselves forward, right? Because if you're pushing downwards, you don't move down, you actually move the opposite direction. And there we have our three laws of motion. The first, an object at rest stays at rest. The second, forces related to the mass and acceleration of an object. And the third, every action has an equal but opposite reaction.